In the second principle of Mendelian's principle, that is the principle of independent assortments, or law of independent assortments, which describes double factor inheritance. In this inheritance fashion, just like in Mendelian's first law that explains monohybrid inheritance, this law tried to explain or describe dihybrid, that is two-factor inheritance. In this inheritance, Mendel advanced. In the first principle, he studied one or single factor traits, how the single factor can be inherited. And then he advanced it to studying two factors at the same time and come up with a law that describes it as law of independent assortment. Now, in this law, before I state what the law explain, quoting Mendel, I'll first of all take you to what he described as double factor inheritance. He tried to work on two traits, basically still using the same organism, garden pear plants. But this time he studied two traits. At the go. The two traits were seed color or seed coats. That is two aspects you look at under the seed coats, where seed coat can be seed color as well, color of the seed, where he noted that some seed were yellow, others were green. But he later discovered before he crossed that this yellow were predominantly dominant. So this is what dominance. And then this one is controlled by recessive traits. And then this is the first trait. And then the second trait was seed shape. Seed shape. Under the seed shape, there are two things we are looking at. One was that the seed, round seed. He discovered that the round seed was dominant. And then wrinkled. Wrinkled will be recessive in that manner. Recessive. So look at the two traits here. Seed color, seed shape. Okay, let me describe these two here. This is the seed shape. This is round. So gene for round, this is round. And then I'll use this to describe color of the seed, color of the seed, color of the seed. And then this stripe, I'll take it to be yellow. So there are two things here now, which is round yellow. So this is phenotypical or phenotype, round yellow for the first one. And then for genotype, I can use this for round and this for yellow. So let this be genotype for the cross. And the other aspects is the aspect of seed coats that is green and seed coats that is wrinkled. So I'll use this as wrinkled. It's wrinkled. And then wrinkled, not only that it's wrinkled, but it is wrinkled and at the same time green. So I'll use spotted for green. So this is not shaped, is not round, so it is wrinkled, 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 and the spotted is green. And then the gene for wrinkle, opposite of round, will be wrinkled, and then opposite of green will be this. So, but genes here, this is phenotype, and this is genotype. And then This 2 is dominant according to Mendel as of the time it was crossing this, and then these 2 were recessive. Okay. The difference between this cross and the other one is that you are looking at 2 things at the same time. So a cross between this shape is round. I will take this stripe to be colored yellow. If I had the yellow marker, I would have used it to describe the seed coats, the 2 threads we are looking at there. I'm crossing it with this thread again. One is wrinkled, not just it's only wrinkled, 2 threads at the same time, and the color of this seed is what? Green. So this is wrinkled, green. So Mendel crossed the 2, and surprisingly, what he discovered was this. So what is this offspring? Call it F1. The outcome of this is not wrinkled green, but all, not only one, but all. If it is thousands of these produced, all are round yellow. Why round yellow appearing in the case of village relationship? Because this is dominant. A character that is dominant will always dominate the recessive character if both are found in a heterozygote condition. So that is the case of this inheritance. But like he did in fixed principle, he's trying to do that as well, knowing that having crossed these 2 characters and did not see wrinkle and not see green, out of curiosity, Mendel decided to self this one, selfing it. Okay, now let me do this way. Supposing I have the parental phenotype, physical appearance. I'm crossing around yellow versus what? Wrinkled green. Dominant and then recessive. Now, the parental genotype will be, this is for round, is monohybrid, that is what is monohybrid, but this is dihybrid, so 2 traits are studied at once, and then there's recessive, so far they are small letter. Then, the principle of segregation still happen here. This we segregate, but there's a great like this. So that means instead of 1, it will be 1 for round, 1 for yellow. That's double factor. 1 for round, 1 for yellow. Same thing here. 1 for green. Sorry, 1 for wrinkle, 1 for green. 1 for wrinkle, 1 for green. So this happens during meiosis. So this is what the gamete has now. Gamete. So cross between this and this will produce capital R. If I take one here, small r. Capital Y, small y. This with this produces same genotype offspring. This with this same genotype offspring. This with this same genotype offspring. We call this F1 generation. Just like we have here, all around yellow. This is round, this is yellow. So far capital is dominating this one. Here is round. Every offspring here are all round yellow. No round green in any way appearing. That is when this is done at random fertilization. The out of curiosity, Mendel also tried to know why the wrinkle green did not appear. He decided to self the outcome of F1. So selfing F1 to obtain F2. Selfing of F1. When I self F1 now, that means if this is going to be the first parents now, since this one now, when they are not going to sexual matured ability, it becomes now second parental phenotype is still round yellow versus round yellow. Okay, then the second parental genotype still give us what I have as this, and then this times. It's not the same thing with this again, but they are same round yellow times this, and this. Okay, then during segregation of this, we have this, and then this. If this go with this will go with this, and then this will go with this, and then this will go with that. But this outcome here will produce 16. Outcome of this F1 advancing to F2 will produce 16 offspring. Just like monohybrid, this is the hybrid two-factor inheritance. It's like the hybrid gave us 4. So if the hybrid gave us 4, so dihybrid, if mono give 4, the hybrid will give 4 times 4, which is 16. So there's no way we're going to cross 16 in this way. So the best way to present 16 offspring in as far as second filia is concerned is to advance it and present it in a Punnett square. That's what Punnett square. So this is how the Punnett square looks like. A Punnett square, a Punnett square. This is a more convenient way to present our outcome. Okay, so the Punnett square will have 16 boxes. 1, 2, 3, 4. 1, 2, 3. 16 boxes. Number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and then I have the offspring here. This is going to be how it will be arranged from the cross here. So this against this. This against this. So we go with this. This is going to give you RrYy. So I'm seeing here, it's going to give you RrY small y. This go here we have R, then big Y, and then we have this R, small r, big Y, small y. We have this, then big Y, small y. Make sure that the capital letters come forth before the small letters. We have here R, small y, We have here R, small r, big Y, small y. And here we have R, small y, You have big R, small r, and then big Y. That's what we have here in the 9th box. In the 10th box, we have this and this, and this. Here we have this and this, and this. In the next box, we have this and this, and this. Next box, we have this and this, and this. This we have. Okay, you have this, and here you have this. Okay, on the interpretation of what I have on the box there, supposing that all round what I have here is first, I'll check how many round yellows I have there. Let's start with round yellows. This is a round yellow, round yellow. For box 1 is round yellow, round yellow. Box 2 is round yellow, round yellow. Even though that this is green, but so far that this capital letter is present, is going to mask this one. 3 is round yellow, 4 is round yellow, 5 is round yellow, 6 is not round yellow, 6 is round green. Remember, this is green. 7 is round yellow, 8 is not round yellow, I jump 8, 9 is round yellow, 10 is round yellow, 11 is not round yellow, 12 is not round yellow, 13 is round yellow, 14 is not round yellow, 15 to 16. So how many out of the 16 offspring are round yellow here? We count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So total net come of this is 9. So we look at a possibility where we can obtain round green. Let's see round green from the box. I'll start with box 6 is round green, round green, round green, round green. 8 is round green, round green, round green, round green, round green. 14 is also round green. I don't think there's any other round green there. So how many are round green there? We have what? We have 3. And then we are going to check wrinkled yellow. How many are wrinkled yellow there? Wrinkled yellow, we have box 11 is wrinkled yellow, 12 wrinkled yellow, 15 wrinkled yellow. Total is 3. And then wrinkled green, how many there are wrinkled green? Wrinkled green is only box 16. Total is 1. So therefore, phenotypical ratio of dihybrid inheritance is 9:3:3:1. So out of the 16 balls, 9 are round yellow, 3 are round green, 3 again are wrinkled green, wrinkled yellow, and then 1 as box 16 is wrinkled green. So every dihybrid inheritance Mendel carried out in his useful work genetics will always produce this dihybrid ratio, which is 9:3:3:1, just like in Mendelian's first principle, where the total outcome of the phenotypical ratio is just 3:1. For all monohybrid inheritance, the phenotypical ratio will always be 3:1. For all dihybrid inheritance, so far that gene is not on a linkage, it's not a linkage character, it will all present in the ratio of 9:3:3 and 1. So what it means that in this inheritance pattern, that genes here during meiosis, they tend to independently assort themselves. If you look at what we have from the first filial generation of this outcome, where we have both parents, these parents crossing with these parents, and at the first filial generation we have this. This is what you have. But if you tend to look at what you have at the table, this table is all about second filial generation. You find that there are some offspring that independently does not look like these two or this offspring. So many of them look like that. Like I can give you so many outcomes, so many parents up to out of system up to 7 or 8 here. We look genotypically different from both parents, and even the offspring of F1 generation. So in this inheritance, genes here, alternative recombinant form of gene tend to assort independently. But apart from these two principles of Mendelian's principle, the third law, which is somehow linked with the first law, which is the law or principle of dominance, which states that in every kind of inheritance that is involving a dominant and a recessive character, that the outcome of the offspring will always be a dominant character. That means the dominant factor will take precedence in the first filial generation. That is the law of dominance, which concludes the three laws of Mendel, which is the law of segregation, law of independent assortment, and the law of dominance. But there are inheritance that deviated from this principle, the first principle, the second principle, and the third principle. I would like us to look at these principles that deviated from these three laws.